So this is lecture 7 for Anthropology 202, Human Evolution. We are in part 4 of the class where we're looking for evidence for human evolution for the more distant past. So to begin, to kind of situate ourselves vis-a-vis this last lecture. So the oldest Homo sapiens, the oldest humans that we have, we call those Archaic Homo sapiens in terms of the archaeological or fossil record. And we observe that the existing Archaic Homo sapiens fossils have a different morphology than us. And if we look at the archaeological record that they're associated with, then we also find that their behavior, right, differed from later examples. Probably the easiest way to think about this is in terms of the use of domesticated plants and animals and residence patterns, right? So we see this sort of evidence for human evolution moving into the oldest remains for Homo sapiens or human beings. And then beyond that, we began to look at other species of the genus Homo. So that once we get into archaic Homo sapiens fossils and data, one of the issues, right, that begins to emerge is that we need to be able to differentiate archaic Homo sapiens from other species of the genus Homo. Once we're looking at those oldest fossils for human beings, right, that becomes a central issue, is that Homo sapiens share some traits, right, with other species in the genus Homo. We can think of derived traits that the genus Homo shares, but does not have shared traits, right, with older and ancestral species. We can think about those traits as being derived, and it's consideration of those traits, right, and those changes in those traits through time is precisely what we mean when we talk about evolution. Now we're even going to go earlier and go beyond, right, the genus Homo to those ancestral species. So in a way, it's a similar kind of problem to when we get to archaic Homo sapiens, and we need to differentiate them from other species within the genus. Once we begin to look at these other species of Homo, and we begin to move back in time to the origins of Homo, we are again confronted with this problem of differentiating other genus, ancestral genus to Homo, right, from the earliest members of the genus itself. And the name of the genus that is ancestral to Homo is known as the Australopith. And these are ancestral to our genus. They are ancestral to the genus Homo. They're a very interesting genus. They were restricted to Africa. So unlike the genus Homo, where we saw several expansions out of Africa, and very characteristic of the archaeological record, right, for the genus, for Australopith, we do not see an expansion beyond Africa. We see them restricted in terms of their habitat to Africa. These species that make up the genus have a very small brain capacity, but they are bipedal. Very interesting, and I think it's something that was not expected in the earlier periods of research into human evolution, that we would find Australopithecus, ancestral to Homo, to also be bipedal. We also see that they are more sexually dimorphic than in the genus of Homo as well, in the sense that we find greater differences between the anatomy of males and females in this particular genus than we see for the anatomy of males and females in the genus Homo. So one of the things that the text talks about and is sort of important in evolutionary theory is that we believe that for the genus Australopith, that they would have had smaller social groups than that of Homo. And one of the ways that we can see that is in the sexual dimorphism. One of the things that we see is the expanded development of the canines. And since canines are often used for defensive purposes and for purposes of aggression, that we believe that there would have been competition between males for females among Australopiths. And one of the ways that you could see this is in the sexual selection for these particular kinds of canines, and for males, right, that would have had that ability, that aggressive ability to outcompete males, let's say, that didn't have that development of the canines. So with this kind of anatomy, with this kind of morphology, we think that we can infer some elements or aspects of their group size and their kind of social behavior, which we do not believe it would have been as developed as in the later Homo genus. So a classic example of the Australopithecines is the Lucy skeleton. It's one of the most intact of the early Australopithecines. About 40% of the entirety of Lucy's skeleton is remains for us today. And this is dated to about 3.3 million years before present, right? So we are far beyond the evidence we had for the genus Homo at this point. In this particular stratigraphic layer, right, geologically, we do not find evidence of Homo. Homo has not developed yet, right, when Lucy and other Australopithecines are inhabiting Africa. Very small, so about 3 to 4 feet in stature. We see that sexual dimorphism with Lucy. We believe Lucy's diet consisted mostly of fruits, nuts, and insects, and little meat. In fact, many of the Australopithecines are not found in association with stone tools at all. And so there is this debate of the degree to which the Australopithecines are actually tool using. Now, Lucy was found with some evidence of tool making. And in fact, the evidence of tool making that we find in association with Lucy would be some of the oldest evidence of tool use in our evolutionary line, in our evolutionary trajectory. So we think by about 3 million years, with the stone tools found in association with her fossil remains, that we do have some tool use, although it's debated. Since we don't find tools widely associated with Australopithecines, there is room to debate the degree to which they were tool using, or potentially, let's say, experimenting with tools. Tool use happening at a population level of the Australopithecines rather than something that would be biologically innate and something that they simply all exhibited as part of their behavioral repertoire.
It was a Sunday morning back in 1974. So I came up here, looked at this, had no idea what was waiting. It was right in this area, right here. What I saw was a fragment of bone, and I looked at it and almost instantaneously said, that's a hominid.
Wow.
Once we broke that 3 million year barrier, it was a whole new picture of what our earliest ancestors looked like. One of the most exciting moments of my entire career.
Lucy made headlines around the world because although she looked a lot like an ape, she walked on 2 legs. She was a biped, and at that stage, the most ancient anyone had ever found.
Beautiful view of the camp.
Her bones are some of the best evidence we have for what early bipeds looked like.
Now, of course, if this were all articulated properly, you know, the vertebrae on top of one another, she'd be about 3.5 feet tall. You don't see that.
Yeah, you don't get that.
Here's the femur.
That's the left.
Top end of the thigh bone.
And this one also, I mean, when you put it all together, now you have, you know, this is telling bipedal, this is giving a hint of bipedal.
This certainly tells it was bipedal. That can't in like that, which is very characteristic. Our knees are close together and they come up to the side. The chimps come straight up. So that's another very important aspect.
Having the upper and lower leg in a straight line is no good for a biped. It makes for an awkward, waddling gait. Lucy's legs formed an angle. Her knees were close together, just like our own knees. This positions the feet directly underneath the body, making walking easier and more efficient.
There we are.
Lucy walked much like us, but she wasn't human. She had many primitive features too.
Isn't it interesting? They had the pile of bones. You put her here, and all of a sudden you could see that it was a living person.
She's beautiful.
Yep. Thank you.
So when we begin to explore the development and emergence of the Australopithecines, it is important to think about what is happening in terms of global climate change. So these Australopithecines clearly emerged in what we call the Pliocene. And so this was during a period of climate change that is coming from the Miocene into the Pliocene. So when we say they emerged in the Pliocene, they're emerging these conditions, right, of change out of the previous geological epoch, or, the Miocene. And from the Miocene to the Pliocene, we're having a cooling. If you will recall, the evidence, if you'll recall, the later evidence for the genus Homo develops right through what we were calling those ice ages. So it was a period of time in which the Earth was much cooler. Well, when we're thinking about the Australopiths, they're emerging just at the beginning of this cooling process. And in fact, it was a period of time in which the Earth was much more hot. It was a hotter and in many ways wetter Earth than it would have been when the ice begins to expand and the ocean levels begin to drop and so on. For the region of East Africa that we're looking at, we have the breakups of very, very dense forest tropical landscape in this period. Those deep and dense forests begin to fragment into a more diversified landscape of different kinds of tropical forest, but then woodland and deciduous woodlands, as well as some savanna and grassland. And this is a period of time in which the grazing herbivores, the hoofed animals, begin to expand throughout the world, where in the Miocene they were less common because you didn't have the expansion of grasslands during that period of time. There wasn't the grasslands on the Earth in the Miocene. So with this change, right, we begin to see simultaneously, right, as the broader climate's changing and these local ecosystems in East Africa begin to change, the primate adaptation to those ecosystems also begins to follow new trajectories. And we begin to see the emergence of the Australopithecines. We begin to see bipedalism. We begin to see new kinds of subsistence strategies. And it's interesting, if you look at the image here, we can really understand why we would see some of the changes that we might see, where we see some of our close primate relatives who still live in Central Africa today, who inhabit what we could think of as fossil or relic forests from this period of time. So they live in some of the ecosystems that have continuity actually with the Miocene. And most Earth ecosystems don't, but that tropical area there in Central Africa, the landscapes and the habitats that we associate with, let's say, chimpanzees and mountain gorillas, those are relic forests. Those are ancient forests, and they have maintained the kinds of resources, right, that allowed chimps and gorillas to develop in the way that they did. But where we find our fossil evidence and where we find Australopithecine evidence, we're seeing a change in that region, and we're seeing the emergence, right, of the Australopithecines coming out of the adaptation, right, to those new conditions. Now, of course, during the Pliocene, there were other hominins, and it's pretty incredible the richness, right, of the hominin evidence that we would see. This is clearly some of the most cutting edge area of this research. So at this point, before Australopithecines, so now we're getting to early primates, if you will. Look at some of the dates here: 5.4 million, 5.5 million, 6 million, 6.5 million. Very, very long time ago. That there still are bipedal hominids that we have biological relationships, and some of which are ancestral to our own. And that's where the debate is today, the cutting edge debate today. When we start going to the genuses before the Australopithecines, so we go beyond the 2 million, 3 million years ago and what we find in the archaeological record. We go before that. We don't see the Australopithecines anymore, right? We see other kinds of genus. And this is where our understanding is today. We don't fully understand the relationship between Australopithecines and these early genus. Lots of ongoing theories, lots of ongoing discussions, and this is kind of where the future of this research will go as we continue to unearth new fossil discoveries and we continue to add to the archaeological record. So here's a 47 million year old primate fossil. So this would be some of the very earliest, right, of the primates, this particular class, and all of the genuses that fall within it, all of the species that fall within it. So this is very, very early fossil for our ancestors. And our ancestors for the primate class, or the primate order, excuse me, they're going to go back to about 65 million years, so even earlier than the fossil you see here, when primates then are diverging from other placental mammals, including those mammals that go on to become rodents. And that's why when we began, I was using the idea of a tree shrew, because these early primates, in fact, are about the size of a tree shrew, and a tree shrew itself is very similar anatomically or morphologically with small rodents like mice and rats. And so when we get back to 65,000 years ago, we are closer, let's say, to the emergence of mammals, and mammals are small at this point. There hasn't been a lot of development in the mammals. So at this point now, we're in deep time, right? And we're looking at the very earliest evidence of primate evolution. And there's evidence to be found too. There's a lot, I think, that we'll learn in the future about this period of time, where we have about 200 recognized primate species from as early as 55 million years ago. So really, really interesting to watch the way our understanding of this early period of primate evolution develop. So in conclusion, we were looking at the very last, right, of the earliest fossil evidence for human evolution. We looked at, from the last lecture, the genus Homo, and now we've just gone back further in time to look at the Australopiths. From the Australopiths, right, we continue to go into deeper time with the Pliocene hominids, and in fact, Ardipithecus, which you have a documentary of there on Canvas for this week. Highly advised that you check out that documentary. And then we moved into the Miocene, right, climate, and then the Eocene with the very earliest primates and their differentiation from other related mammals such as rodents.